Hi everyone, welcome to my channel Pure Biology, and today's topic is the continuation of regression coefficient, and it is the third part of the regression coefficient where I will discuss about the problems, okay, different problems. So before this topic or before this discussion, first you have to check out the previous videos because there I have already explained more information related to regression, and after that you say this one because without seeing that you cannot understand about this. So before going to this topic, I want to say thank you to all of you who have subscribed my channel. So here is the problem, that is the following results were obtained from measurement of body length y and the body weight x of 25 anabas sp. What are the informations we see here? Summation of x square, summation of xy, summation of y, summation of y square. So here with this information we have to calculate appropriate regression line of body length on body weight, okay, body length y on x, okay, coefficient equation y on x. So first of all, what we have to do, that is what one second, this is not okay. So first we have to calculate here byx, and the formula is, with the help of this we have to calculate this byx. So formula is that one, n summation of xy minus summation of x summation of y divided by n summation of x square minus summation of x whole square, okay, and n is here 25 here. Now putting the values, 25 into summation of xy is what, this one, 9024.4 minus summation of x is what, this is 116.5 into summation of y is what, this one, 185.2 divided by 25, then summation of x square is what, this is this one, 56947 minus, and summation of x whole square means this one, 116.5 square. Clear? Next, multiplying by this, answer is 225610 minus minus by this 215758. Here multiplying by this 1423675, and by squaring this 1357225. Okay, so answer is what? By subtracting this, answer is 985252 divided by 66450. So answer is 0.14826, or you can write 0.148 approx. Okay. So the value of byx, that is 0.148. Next, the equation. The equation is y minus y bar equals to byx, x minus x bar, because here the equation is what? The body length on body weight. Body length is y, that means the regression coefficient equation of y on x. Okay, so equation is this. Now putting the values, y minus 7.408, here the value of byx is 0.148, and x minus x bar So x minus x bar is 46.6, 46.6. Where is that? X bar is, y is that? X bar is, okay. You have to calculate the x bar and y bar also. Y bar equals to summation of y by n. So by putting the values 185.2 by 25, so answer is 7.0408, and x bar is summation of x by n, that means 116.5 by 25, so value is here 46.6. Clear? Now what is the answer? Y equals to 0.148x minus 6.897 plus 7.408. So answer is 0.148x plus 0.511. Okay. So this is the coefficient equation. And here we have to find out only the y equation, so x equation is not necessary here. So this is the answer, and in graphical method, if we plot or by putting the values of x, then we will get y values, and here after that we plot the values of x and y, then we will get a straight line. I think so. So you can check out in obviously in home or in your own copy, that is it showing the straight line or not. Okay, by putting the x values and you will get the y values. Different types of putting the x values, we will get y values, and in such way the y x, in such way we will get the x and y values. Okay, and these values, if we plot it on the graph paper, then we will get a straight line. So this is the one problem solved here. Another two type of problems obviously today we will solve, so continue with me. Okay, here is problem that the following results were obtained from records of age x and systolic blood pressure y of a group of 10 teachers of a college. And here summation of x minus x bar into y minus y bar, the value is 1220, and find the appropriate regression equation and estimate the BP, blood pressure, of a teacher whose age is 50 years. Clear? So here first of all we have to calculate the byx value. Okay, and regression equation of y, that is y means y, it is y because blood pressure, the systolic blood pressure, find the appropriate regression equation of the blood pressure. Okay, and here the blood pressure is y, so regression equation of y we have to calculate. The equation is that. So first we have to calculate byx, and here the calculation of byx is not in the previous way. Okay, here the calculation is occurring in such way, that means COV dot xy divided by sigma square x, that means xy value of this. How to calculate the value of this? Actually this value is divided by number of people or number of individual. So this is the value of xy. Clear? And this xy value is putting here, and sigma square x is 130 because sigma square x is 130. Okay, here this is sigma square x 130 and sigma square y here that 165. So by putting the value of 130 we will get the byx value. Okay, and here after getting the byx value, the method is same. Just after writing this equation we will put the values, and here the y bar, that is what, 142. Where is y bar? This is, okay, this is y bar. Okay, and this is the x bar because mean is there here. So y minus y bar, just putting the values 142, here 53, 0.94, and after the calculation we will get this. Okay, and here find out another thing. We have to find out another thing, that is the blood pressure of a teacher whose age is 50. That means age is variable x. So value of x is age. So just putting the value of x. Okay, just putting the value of x. So what is the value? This is okay, and here you can properly understand that 0.94 into x. Okay, into x. So just putting dot here. If there is any confusion between the multiplication sign and the x, so that's why I just put here dot. So after multiplying and adding, we will get this value. So this is the process by which we will calculate this value. Okay. So it is the process where anything is not seen, only the value of this here and value of the mean of variable is here, and variance, that means sigma square and sigma square x and sigma square y is there. In that situation we have to calculate the sum in such way. Okay, and here you have to memorize that byx value is calculated here in that way, covxy by sigma square x. And what is this? This is the actual value of this divided by number of individuals. Okay, number of individuals. So we get here this value, and just putting this value here we get here this value. Okay, so here after getting this value, just we put this value in such a way or in the equation, then we totally got this value 139. Suppose this one, this is the actual value of y. Okay, so I think you understood the total solution of the problem. And the next one, the last one, related regression coefficient, today I will discuss with you, and this is the last problem that is related to the regression coefficient. Okay. Okay, so here is the problem is that y value is there and x value is there. Okay, then how to calculate dy value, dx value and dx dy value? First we have to add all these variables related to y series, and what is the value? That is 500. And now we have to calculate the y bar value, that is 500 divided by the number of individuals, that is 10. Answer is so 50. Next, summation of dy. How to calculate summation of dy? This is actually y minus y bar. So these are the y values, and you just subtract this y values by y bar value. This is 50. So 45 minus 50, 55 minus 50, 45 minus 50, 50 minus 50, 60 minus 50, 70 minus 50, 35 minus 50, 55 minus 50, 50 minus 50, and then 35 minus 50. So we got these values. Okay, these values, these are all the dy values. Okay, and here the summation of dy is 0. And after that, what we have to calculate? That is the dy square value. Dy square value is nothing but just squaring the dy values. So 5 square minus 5 square, 5 square minus 5 square. So by squaring these values, we got these values. Okay. So summation of dy square, this is the actually adding these values, then we got these values. Okay. And here the x values, similar way, just first we have to calculate the x bar, adding this and dividing by the number of individuals. So x bar is there, that means just calculate x minus x bar. So x minus x bar, you can see that 20 minus 31, 35 minus 31, 25 minus 31, 30 minus 31, 40 minus 31, 45 minus 31, and 22 minus 31, 40 minus 31, 30 minus 31 and 23 minus 31. So these are the all dx values, and by adding these dx values we will get always dx summation of dx 0. Okay, then squaring these dx values we will get that the dx square values. Here the values are these dx values, so just I squaring these values I got these values. Okay, then summation of dx square is nothing but just add these values, then we will get this value. Clear? So dx dy, you just multiplying dy and dx, then you will get these values. Okay, dx dy. Suppose first one 11 and 5, minus 5 and minus 11, answer is 55. Then plus 5 and plus 4, 20, minus 5 minus 6, 30. Then 0 and which one? 1 second. Minus 1. Okay, first I have to check. Sorry. Okay, you just see here, sorry, I was checking where the value is right or not. So 0 into 1, that means 0, and 10 and then 10 and 9, so 90, and then 14 and 20, that means 280. Ignore the noises, I just request you. 15 and 9, then 5 in and 9, and 0 and again 1, 15 and 8. So these are the values of dx and dy. And then we have to calculate summation of dx dy. Then very easy, byx is summation of byx, because here they want to know the regression equation of y on x, so that's why. So we have to calculate the byx value. Just a summation of dx, summation of dy by summation of dx square. So that is the value is this one. Okay. So just putting this value y minus y bar equals to byx into x minus x bar. So y bar is here 50 and x bar is here 31. Just put the values 50 and 31 and 1.14. So we will get this one or this equation. So here y equals to 1.14x plus 14.66. This is the actual equation of y on x. So if the problem is in such way, then we have to calculate this regression equation value of y on x in that way. Okay. So total regression equation related problems, different types of problems I have already explained in my three videos. So you check all the videos.